In the last video, we left off with number 6 from the quiz for polyatomic ions, and that was to find a name for this compound here. And okay, so the first thing I need to do is identify which is the cation and which is the anion. And if you're familiar with your cations and anions, or if you have a chart of different cations and anions, then you can look and see where the division is, because we have a lot of different things here. You know, is N my cation and then H4ClO my anion? Well, if you're familiar with the different cations and anions, then you could see that the only way to split this up is the NH4 and the ClO. Okay. Now we run into the question again: is, you know, was this like, you know, -3 and a +3, or, you know, what was the charge here? Because we don't know when there's no subscripts down here. They must have the same charge, but we don't know if that charge is, you know, +1, -1, or +3, -3. We have no idea. So in this case, after you've identified them and you've split them up, I think the best thing to do, if you don't have it memorized, is to just look at the chart and say, okay, I'm going to start with this one. And then you try to find this on there. And you should identify right away, this is one of the only polyatomic cations that we've learned about. And since that's the case, if you have it memorized, you would know that this is +1. Therefore, this must be -1. You could also have done it by looking up this first, and you'd see that this, in fact, is -1, and that would be +1. And then you could just check both of them by looking them up. So, in this case, the name for this is ammonium, and this is one of the oxygenated chlorines. And we know that it goes from ClO4, ClO3, ClO2, and then ClO. Since that's the lowest one, it's the hypochlorite, and this ion is called ammonium. So that's ammonium hypochlorite. That's the name of that ion, or that ionic compound. So, now that we've done some examples, there are a few areas where these can get really confusing. And two of them that I could think of is if you have something like this and something like that. So in both of these cases, we don't have any subscripts. You might think, oh, well, there's a subscript right there, so that must be Fe, you know, 4+ and PO4, you know, 4- or whatever. But that's not the case, because remember, anytime you have a polyatomic ion, this behaves as one unit. So if there had been a subscript for that one unit, there would have been parentheses here, and then a subscript down here. But that's not the case, because as written, there's no other subscripts or anything like that. And the same thing here, there's no subscripts there. So really, when we split this up and try to figure out the name of it, then we have a lot of different possibilities to go from. This could be iron +1 and oxygen -1, or it could be Fe2+ and O2-, Fe3+, O3-, and we don't know which one it is. Because the problem here comes from that we have an ion that's a transition metal. Remember, the transition metals do funky stuff like this. They don't always have, you know, 1 or 2 or whatever. But luckily for us, we could see, oh, wait a minute, oxygen is one of those predictable ones. It's in group, I think, 6A. So therefore, it's going to have a charge of, and if we look at the periodic table, we could say, okay, well, it has to have a charge of 2 minus because it likes to gain 2 electrons. And if you have the notes down that we had up here earlier, then you see that this is ruled out because oxygen doesn't like to gain only 1 electron, and it definitely doesn't like to gain 3. It's only going to gain 2. And so now we could rule out these possibilities and say, okay, it had to have been this one. So what's the charge on the iron? It's 2 plus, so it's going to be iron 2 in parentheses, and that's oxide because it's a monoatomic ion. So it's ox, you drop the last syllable, and add I. Now with this, we have the same problem. Was this iron 1, iron 2, or iron 3, iron 4, iron 19? We don't know. But this polyatomic ion is predictable. Just like this monoatomic ion was predictable, generally these polyatomic ions will always be predictable. And if you get in the habit of, or if you've memorized them, or if you have a chart with you, then you can just look up PO4, and you'll see that it has a charge of 3 minus. So, well, if we look at the different possibilities here, it must have come from 3, the iron 3, because PO4 3 minus, that would give us like charges, and then we could just say, okay, well, one of these, if it's attracted by one of these, it automatically cancels out, right? And we're already at 0. So it's not going to need to pull any more or any less. So it's going to be a 1-to-1 ratio. And yeah, so that makes sense. So therefore, this must have been iron 3. And the name of that is phosphate. So make sure you put your parentheses there. That would be iron 3 phosphate.